Arvin, carrying on with our discussion about filtration, I'm really glad you've let us take the lids off and we can have a look at what's happening here. But I'll just quickly describe the flow. We can see the water coming out of the fish tanks.
Yeah.
It first goes through the two swell filters, both ends. Then it enters into the centre of the up-down filter, doesn't it? And we can see by the up-down filter, sorry, the outsides, it's entering the outsides. So this barrier helps make more of the solids fall out, doesn't it?
Here, yes.
And then it goes in the middle. I notice you've got K1 in there, in the middle of that.
Yes.
So that's moving around quite slowly. Why is that there?
That's just there to make sure there's surface area for the microbes to establish.
So we want the microbes to be doing work even at this early stage.
Yes.
Then the water comes out of the centre into this
here,
one.
yes.
And this is really a big biofilter, isn't it?
It is.
And we've got lots of this wonderful material in there.
Exactly, yes.
K1. And we've got lots of vigorous aeration.
Yes.
All through the tank. And the water then goes from there
into the sump. It
back
flows
to the
up
sump.
there's an elbow at the other corner and goes into the sump.
So this is what you mean, I think, when you could describe it as standalone.
Yes.
It's actually its own loop, isn't it, in the system?
Correct, yes.
So we'll just recap. Out of the fish tank, bringing with it solid material.
All of the solids.
And the solid materials, majority of it get caught in the swell filters. And then some of it, more of it will be caught in the up-down filter.
Yes.
Because the water comes in and has to rise up to get over that barrier.
Yes, so it has to do work to get up, which way it drops off
so
the
the heavy stuff
load.
drops off, And then in the middle here, we're already starting on the biofiltration process, and that is getting the microbes to start doing their work.
Yes, the initial bit of breaking down starts there.
Because even though I pick some water up here, and I know it's red because of the iron, but I actually can't see any solids, but they're there, aren't they?
They're there, yes.
They're
suspended in the water, which is why we have it in stages of less to more.
Yes.
So when you go through the initial bit of filtration, they're already chewing, or they're already starting to work on the breaking it down. And then as we go into the next stage, it's already a slightly simpler form where the other microbes can then get in. So the microbial activity is already processed.
Wonderful. It's simple, but ever so necessary. So these are beautiful big tanks. Approximately how many litres are these?
This one is about 2,500 litres.
Same with that one?
Same as that one.
This
is a 3,000 litre tank.
3,000 litre tank, so we've got quite a bit of stuff going on.
Yeah, and most of the cone bottom is buried underground, so you probably don't see like 25% of the tank.
Okay. I should say that the water level is set by the final outlet here in this case, isn't it?
Yes.
So it's coming through from there. The tank is higher,
Yes.
comes into there, drops down a little bit to here, and so on it goes.
Yes.
So that's it really, isn't it? It's disgustingly simple. Now over here we've got what you've got tagged green water tank, but that's actually a mineralisation tank or another biodigester, isn't it?
Yes.
So what do we do with there? Let's walk over there and take a look at this one and talk about that.
Perfect.
The next stage, or one of the other stages we talk about, Arvind, is actually mineralisation or biodigestion to a further level. So the waste that we collect in the swell filter, for example, winds up in here, doesn't it?
Yes.
And it's tagged a green tank, but it's actually a mineralisation tank, or the final biodigestion.
Yes.
So you put it in here, you vigorate it for how long?
We let it sit in there for at least 25 to 35 days, depending on the season. And you'll notice that over a period of 1 year, when you run a farm, you'll only accumulate about half an inch of sludge at the bottom of there.
So you fill it up one day and you've probably got sludge, let's say 2/3 full.
Easily, yes.
Yeah, then you set it on its way.
Yeah.
And 35 days later,
it compresses. Yeah.
Because it's been broken down,
broken down by the microbes.
Yeah. The biology's eaten it up, separated the raw components out, the magnesium and the whatever else you've got.
Yes. And all the sugars that are there inside, the complex sugars, that get broken down by the microbes. And we get a very high concentration of nutrients in that water, actually.
I love to call it a word called elixir.
Yeah.
It seems like you'd almost eat that, doesn't it? But that's where you get the really high quality stuff from.
Yes.
So then after 35 days, you let it settle and you drain that into the sump.
You drain that in there. It's almost like a compost tea brewer.
Yes.
Just that the compost is coming just from the fish waste that's collected from our filters.
Very important process.
It is, yes.
So a homeowner can do this.
Yes, they could.
Even if they don't have the room to make an up-down filter and a moving bed biofilter and all that stuff, they can most certainly do this.
Oh, definitely. You could get a couple of blue barrels, 50-gallon barrels, line them up. One could be a swirl filter, one could be this, and you could even have an up-down with a blue barrel if you get really smart enough.
If you really wanted to, you could. So interestingly enough, this is not that big a barrel. How big is this one?
No.
200 litres, 300 litres?
Yeah, it's actually 250 litres. It's a very narrow barrel, so we get a lot of good aeration right through the column.
Because you want a nice narrow column.
Exactly. And we're able to digest sludge that comes out. We're able to tap into all that extra waste that we would actually call waste in the traditional scheme of things. Now that becomes another nutrient source.
Very
it's actually working
process.
in tandem with the fish now.
Yeah, it is, isn't it? Interestingly, just stepping back when we're talking about pumps, we're standing beside a working pump here, and it's not drowning us out with noise.
No, not at all.
In fact, we can hear more water noise than we can pump noise.
It's
good stuff.
Yes, it always helps to get good quality products.
It does. I have to go home and buy some Grundfos pumps.
I'm sure.
While we're here talking about the pumps, Arvind, I know for years now I've been telling people chop constant height one pump, but here we have two.
Yes.
Now, it's a much bigger farm.
Yes.
So you have two. How have you split this up now?
So we use one for the aquaculture to keep the fish
for the
flow,
fish tanks, all that stuff. Yes.
And we use one to go up the overhead tanks and into the media beds and the rafts.
Okay.
Since we don't need a whole lot of water flow that we have going through the fish tanks, we use a smaller pump to go through. Actually, in this one module, there are two independent systems, or two tied-in systems, but there are two systems. So you would, in a chop system, use one pump for the one system and another pump for the other system. So now, instead of that, since the size of the tanks and the flow rates are significantly exclusive, we're using one pump for the aquaculture side, so we have more control for just the aquaculture side, and we have one pump going into the veggies side, so we have enough control going through there.
But just to clarify it, we've got this massive big sump down below here.
Yes.
And that's Grand Central Station
It
still.
is, yes.
So we're still circulating the same water through the entire system.
Exactly.
The aquaculture part, the media beds, and the raft bed.
And the raft beds, yes. We go through three separate loops. So we have a raft loop that empties into the sump again, goes through the overhead tank, through the rafts, and empties into the sump. The media beds do the same thing through the overhead tank, into the media beds, and into the sump. The aquaculture does the same thing from the sump into the fish tank, through the filters, and back into the sump.
So the two pumps really give you more control over the flow rates in a way, don't they?
Yes.
Because to have one pump big enough to do all that,
oh yes,
it would be a very big pump, really.
It would be a very big pump, and to just crank down the valves everywhere and make sure you're getting the exact same water flow that you require will require a lot of monitoring, which becomes redundant if I have a pump that's sized this way specifically for that task.
So maybe I have to change it. Constant height, one pump sometimes.
Sometimes, there you go.
Sometimes two pumps.
Sometimes two pumps.
Thanks, Arvind. And the sump is really big. How big is that?
20,000 litres.
20,000 litres of underground sump. And that's Grand Central Station. And it's a bit of a dark abyss, but if we could see down there, we'd see a lot of water moving around.
Yes, a lot of
Do you have aeration down there by any chance?
No, I mean,
just sheer water movement.
Yes.
Yeah.
We're pushing in at least 30 to 40,000 litres per hour going through that sump.
That's a lot of water.
So that's a lot of movement. And we have all these drains. We have 8 rafts draining in there. We have 12 media bed lines draining in there. So it's a lot of movement.
A lot of movement. I can see it actually, but
there's probably more aeration down there than we have up here.
Yeah, probably. Thanks, Arvind. Arvind, we're standing beside these wonderful air blowers,
yes,
and
aren't we?
as we can hear, they are loud, but not that loud. They're quite acceptable, really. They're really good, made in India.
Yes, they are.
Very high quality. It's really amazing. They're 3-phase.
Yes, they're 3-phase, 2.2 kilowatts each.
And I noticed they produce 350,000 litres per hour.
Yes.
That's a lot of air.
Yeah.
But what people may not realise is that air gets quite hot, doesn't it?
It does.
So this part of the system here is to try and dissipate some of the heat.
Yes.
Because that's actually, I can't hold my hand on it, but only just.
Yes.
So there's a lot of energy being used there.
A lot, yes. A lot of friction between the air and the pipes, which is why it's always better to size up the pipes so you reduce the amount of friction that the air goes through.
So we're coming here onto that looks like 4-inch pipe.
4-inch pipe, yes.
4-inch pipe.
6-inch.
6-inch down to 4-inch, and then it goes
and 4-inch all around.
Distributed all around the place. So we've got 1, 2, 3, 4, 5 of them for the entire farm.
Entire farm, yes.
Wow, up close here, that's really hot.
That is pretty warm, yes.
And this one here is our
intake
air, and it's got a filter on it.
Yes.
Because the thing that blocks up your air stones in the end is dust, isn't it? That comes through the system. So there we have it. Air blowers. These are called regenerative air blowers. They're not piston style air blowers, but they can produce an awful lot of air, but not at very high pressure though, is it?
Not at very high pressure. They don't do very good at very high depths.
Yes.
But they can go about to a meter and a half.
Yeah.
Max.
So if we're thinking PSI for our Americans, what would it be? 2 PSI, 3 PSI maybe?
For the entire farm, it's about 1.5 PSI.
That's all. Not very much pressure, but a real lot of volume. Thanks, Arvind. Very important part. And I can hold my hand on it. I've seen some others that are such poor quality. Oh, burn your hands. So that indicates good engineering.